Statistics for Business, which is a collaborative initiative between Islamic World Educational, Scientific and Cultural Organization and NUST. NUST, SEECS and ICESCO join hands to promote the advancements in data science and AI interventions for business and finance amidst the digital era's data set. ICESCO and NUST's partnership aims to merge academic research with business and financial applications. By focusing on data science research and workforce development, this collaboration supports industries' growing reliance on data strategies, empowering organizations for strategic decision-making and optimal operations. The importance of sustainable energy management lies in its pivotal role in addressing environmental challenges, and AI and data science plays a crucial role by providing advanced analytics and predictive modeling to optimize energy consumptions, enhance efficiency, and facilitate informed decision-making towards a greener and most sustainable future. We invite Mr. Asim Hameed Khan, senior software engineer at SkyElectric, to discuss the challenges and opportunities we have in this domain. So, a round of applause for Mr. Asim Hameed. Asim Hameed, please.
Thank you very much for the introduction. And thank you very much to the chair of ICESCO, and thank you to NUST and everybody. My name is Asim Hameed Khan. Today we are going to talk about the data-driven insights that are transforming the solar system for enhanced business productivity and customer satisfaction. So this seminar is actually organized by ICESCO Chair of Data Science and Analytics for Business. About me, I am a senior software engineer specialized in machine learning at SkyElectric Private Limited, Islamabad. So my responsibilities actually include machine learning, deep learning, computer vision, some of natural language processing, and most importantly, the ML ops and predictive data analytics. You can actually contact me through these links. So let me tell you about SkyElectric. So our vision actually is to provide clean, reliable, and affordable energy available to the whole world through the energy innovation, through involving the technologies like cloud, artificial intelligence. So what actually our mission is, we want to provide clean energy universally available to everybody, not particularly limited to the countries like Pakistan. We are actually moving towards the international market like Japan and United States of America as well. So the whole system is actually managed via the cloud and our NOC team that is actually monitoring the system 24/7. So we handle all the customer support and make sure that your system is actually utilizing its resources at the fullest. So this is actually a preview of our latest version 3.0. And as you can see on the screen that the cloud is actually monitoring the solar system that is actually located at your home. So how is it actually managed? You can visualize all the stuff going on at your mobile apps, right? So on your mobile app, you can monitor how much the load system is actually having, how much your solar panels are producing the energy, right? So this is kind of the basic stuff that you will be looking at. But we provide the most customer satisfaction, so you can actually control your devices through your mobile apps as well. So this is in the bigger picture. This is an IoT device controllable through your mobile, aided by machine learning software. So this actually comes up with a smart energy inverter, right? So we have our smartness introduced in the cloud level as well and the hardware level as well. So it has system management device, we will be talking about more later, and advanced battery pack as well. Right. This is a bigger picture of the whole system, which is the 3.1, 3.0 version of our cloud. So introducing the SkyElectric Smart Solar Energy Solution, and how is it aided by the software. So this SkyElectric NOC, which is a solution as a service for remote monitoring, management and maintenance. So how is it actually monitored remotely? We have a NOC team which actually looks at your systems 24/7. And how does it actually look? We have set of dashboards available to that NOC team, which actually monitors what kind of load your system is actually having, and also most importantly what kind of behavior is currently existing at the system. Like for example, if the load on your system is getting higher than the actual capacity of that system, that you need to be informed of those particular activity on your solar system, right? And so in this way you are actually saving your system from getting damaged. So this is how we all this stuff goes onto the cloud. So in case there is an issue that can be remotely handled, our NOC team make sure that they are handling all those steps through the remote commands that we send through the APIs onto your systems, right? So in case of an emergency, we need our NOC team will make sure that our team visits you on site. So we have built-in energy management intelligence software, which is the patented software of SkyElectric. So this makes sure that you are actually utilizing all your resources available to the fullest, making sure through the artificial intelligence algorithm, which we will be talking further. So these software APIs for customizing the energy management actions. So these can be done through the cloud by the NOC team, or you can also do it yourself through your mobile apps. Advanced touch screen energy control. So you can actually have a mobile app as well. If you are away from home, or on the other side, you can control built-in touch screen that is actually located onto your systems. So you can do any kind of actions that can actually help you automate through all the stuff. Now talking about the security, we have strong PKI-based cyber security for NOC, for cloud and system communities. So we make sure that all these communication actually are encrypted, that are going through your mobile devices, or whether are going through our NOC team. So in order to make the product viable, we make sure to handle all these stuff. So let's talk about smart energy intelligence. So this is actually handled by multi-value stream extraction using AI. So what is the data around this AI? So we actually, on the number one, we make sure the time of use of energy arbitrary. So we are aware that what kind of patterns actually that home was demanding the load through that system, what are the requirements of that particular household. On the other side, we know your local weather as well. So we, based on this weather, we are particularly aware through our AI forecasting that how much actually the load would be in future, and how much solar energy would be produced and consumed at your household. On the other side, we are also aware of the tariff and the bill numbers, that how much bill was actually consumed in the last month and how much bill would be actually predicted in the future. So now we have, if I talk about the average, if I talk about the tariff usage, we have two kinds of tariff usage in Pakistan. Well, number one, we have low tariff, and the other one which is high tariff. High tariff is particularly when you use electricity from grid between 5 to 11 p.m. Right? So the charges of this high tariff are actually quite higher than the low tariff. So we make sure through this AI predictions for load, PV, and grid outages. So we make sure that our smart flow is actually creating the backup for you. Like if I talk about a load shedding condition in Pakistan, it happens from few hours to multiple hours. Like पिछले दिनों में पिछले सालों में अगर बात करें तो ये चीज़ें काफ़ी सारी फेस करनी पड़ी थी कि हमारे कंट्री में कि लोड शेडिंग बहुत ज़्यादा हो जाती थी. So all of this load shedding had some kind of pattern. उस पैटर्न की बेस के ऊपर हमारा सोलर सिस्टम एक्चुअली करता क्या है, ये स्मार्ट फ्लो सिस्टम ये करता ये है कि इसको एक पैटर्न पता होता है जिसकी बेस के ऊपर ये एक डिसीजन लेता है कि इस टाइम के ऊपर मुझे ग्रिड से इलेक्ट्रिसिटी कंज्यूम करनी चाहिए और इस टाइम के ऊपर मुझे अपनी सोलर एनर्जी लोड के लिए देनी चाहिए. और उसके साथ साथ नेट मीटरिंग. ऐसे नेट मीटरिंग यहाँ पे क्या होती है? नेट मीटरिंग ये होती है कि आप जो इलेक्ट्रिसिटी जो सोलर पावर अपने माइक्रो ग्रिड के अंदर प्रोड्यूस कर रहे हैं, यू कैन एक्चुअली एक्सपोर्ट टू द गवर्नमेंट, राइट? सो if there is no AI, then your system won't be actually able to decide कि कब मुझे ग्रिड नेशनल ग्रिड के अंदर इलेक्ट्रिसिटी एक्सपोर्ट करनी है, कब मुझे वो इलेक्ट्रिसिटी एक्चुअली यूटिलाइज करनी है अपने बैकअप के लिए, ताकि ये ना हो कि आप इलेक्ट्रिसिटी प्रोड्यूस जो कर रहे हैं वो एक्चुअली एक्सपोर्ट होती रहे आपके नेशनल ग्रिड के अंदर, और जब आपका हाई बैकअप टाइम शुरू हो तो आप इलेक्ट्रिसिटी कंज्यूम कर रहे हो उस नेशनल ग्रिड से. तो इससे क्या होगा, एक्चुअली आप अपने सोलर सिस्टम से वो फ़ायदा नहीं उठा रहे होंगे जो कि एक्चुअली सारी स्मार्टनेस का फ़ायदा होगा. ठीक है, आप क्या कर रहे होंगे उस हाई टैरिफ में, जब आप इलेक्ट्रिसिटी कंज्यूम कर रहे होंगे थ्रू नेशनल ग्रिड, आपका बिल फिर भी ज़्यादा आएगा आप, और उसका जो इसका स्मार्टनेस का जो बेसिक फ़ायदा है वो आप अचीव नहीं कर रहे होंगे. तो व्हाट वी डू इज़ कि हम ये मेक श्योर करते हैं कि हम अपनी जो बैटरीज वगैरह बेस्ड ऑन सम डिसीजन मेकिंग वो चार्ज कर लें ड्यूरिंग द लो पीक आवर, जिनमें आपकी इलेक्ट्रिसिटी एक्चुअली उसकी प्राइस कम होती है, बजाय इसके कि आप 5 बजे के बाद उसकी इलेक्ट्रिसिटी चार्ज करना शुरू कर दें अपनी बैटरी के अंदर या अपने घर की लोड के लिए यूज़ करना शुरू कर दें. तो सो दो दिस patented smart flow actually makes sure that you get better of your energy resources, whether it is from solar, whether it is from national grid, or whether it is from battery. So what we have here, we have PV, which is solar. We have load demand of that particular household, and we have the outages from the national grid, and also we have weather-based conditions. So cumulative of all these, we make sure that you get more and more benefit of your particular resources. So before we move further into these systems and how they are generating data, let me tell you about the big data. So big data and machine learning. So what actually is big data? Big data is actually the volume considered of 3 V's. These 3 V's include volume, velocity, and variety. What does volume actually mean? Volume means the amount of data. If I talk about any of the IoT devices, they actually produce lots of stuff. They are producing data to the granularity of 1 second even, right? So if you talk about this time series data of 1 second granularity, then this is quite a huge data, right? on our cloud, we have thousands of systems. So on the second side, velocity and the variety. So you want that to have the speed when processing all that data and the variety. What kind of data you can actually save to those systems. So our smart solar system actually are quite huge in number. So these what could be these components? These components could be solar panels. Components could be inverters. These could be energy storage, your battery, right? And there are other components as well. Even the user experience could be part of that. So all these cumulatively combine into a big data. So how do we actually save that data into our cloud? So we have APIs that actually trigger that actually bring the data from your household system and to the our cloud, right? So the data generation includes energy production, environment conditions, equipment status, alerts, usage, right? Your system is actually producing lots of alerts during the day, during the night. So whatever action you take or your system itself takes to improve its performance. So all these alerts, like those alerts could be warnings, those alerts could be faults, those based on their situation. So emphasis on real-time acquisition. These are actually lots of a lot more granular data. As I mentioned that we are even capturing data till 1 second, right? So we actually for multiple situations we actually collect data on multiple granular levels. Those could be 1 second, could be minute, could be hour, right? And combined aggregating all these data, we save them as per our usage. So this if I talk about, as I'm talking about the granularity, this is all the time series data. I'll talk about the other data as well in a few minutes. So how does that data is actually saved? Systems generate values and they through APIs they push them to the cloud. So what kind of databases we have? We have all these stuff situated in AWS infrastructure, right? To make the ease of operation, we have different kind of databases, hybrid nature of databases that are comprised of SQL and NoSQL databases, right? So what we have in our architecture, we have PostgreSQL, we have Elasticsearch or OpenSearch. If OpenSearch is open source version, and ScyllaDB. You might be aware of ScyllaDB in terms of Cassandra DB as well. So in order to give scalability and flexibility, we utilize these three databases. PostgreSQL actually saves the metadata around our systems. So this is particularly not the large data, but large in some nature that it consists of the metadata like what kind of system is it, where is it installed, and what kind of it is installed in, what kind of minor statistics as well. If I talk about this Elasticsearch and ScyllaDB, these are the ones which we particularly utilize for the big data part. So these actually work based on the time series based partitions, right? So this was a kind of overview of how we save the data into our databases. And now let's move towards the machine learning part of it. So what machine learning actually is? Machine learning is kind of pattern learning through your data. So what comes important, your data. So we are generating the data at a very huge scale, right? So if I talk about some of the case studies, there are solar production, how much the solar system would be actually producing the solar energy. So the other one is load demand. So you actually via the solar energy or the battery storage, you actually utilize that electricity. उसमें आप अगर ये ऐसे ही चलाते हैं, आप अगर कुछ और devices चलाते हैं, all these actually combine into a one load value at that particular instance and at that particular granularity, right? And the other part, the outages. Since our country has this issue with outages and load shedding, right? The battery SOC and SOH. So state of charge and state of L. So you might be actually aware of your phone batteries as well. When these batteries actually get drained at their fullest, so they along with period their life is actually draining, right? जितना आप अगर आप अपने मोबाइल की बैटरी को बहुत फ्रीक्वेंट अपने मोबाइल की बैटरी को आप उसके बिल्कुल ही डिस्चार्ज कर देते हैं ना, उसकी वजह से उसकी लाइफ के ऊपर इफेक्ट बनता है. तो बैटरी की जो पैटर्न्स होते हैं ना चार्ज और डिस्चार्ज के, वो यहाँ पे इम्पोर्टेंट होते हैं बैटरी की एक्चुअल लाइफ को प्रेडिक्ट करने के लिए. तो यहाँ पे ये चीज़ इम्पोर्टेंट हो जाती है. तो उसमें ये होता है कि कभी कभी ये होता है कि आपकी बैटरी बहुत ज़्यादा डिस्चार्ज होने लग जाती है, उसका और इम्पैक्ट पड़ता है आपकी बैटरी की लाइफ के ऊपर. उसमें कुछ कैटेगरीज हम लोग एडवाइस करते हैं कि बैटरी डिग्रेडेशन, उसमें एक कैटेगरी होती है अर्ली डिग्रेडेशन. मतलब उसकी जो एक्चुअल लाइफ प्रेडिक्ट थी या उसकी लाइफ जो होनी चाहिए थी उससे वो पहले डिग्रेड हो चुकी है, ठीक है. उस वजह से उसकी स्टोरेज वगैरह पे सब कुछ इम्पैक्ट पड़ता है. तो दिस इज़ वन ऑफ आवर केस स्टडीज जिसमें अगर आपकी बैटरी बहुत ज़्यादा जल्दी डिग्रेड हो गई है तो उसमें अब क्या होगा, आपको बहुत ज़्यादा लॉस होगा क्योंकि बैटरीज आर क्वाइट कॉस्टली, राइट. फॉल्ट डायग्नोसिस, जिस तरह मैं अभी अलर्ट्स की बात कर रहा था, आपके पास अलर्ट्स होती हैं दो तरह की, वार्निंग्स और दूसरी फॉल्ट्स. जो वार्निंग्स होती हैं वो उनका एक इंटरमीडिएट लेवल होता है सिवियरिटी का. जो फॉल्ट्स होती हैं वो दे एक्चुअली कम अप एट लार्ज severity level, right. Another is predictive maintenance and the other one is customer support and chatbots. So if I talk about the predictive maintenance, आपने अगर किसी घर में लगा हुआ या किसी ने कभी सुना हो कि क्योंकि आपके जो सोलर पैनल्स होते हैं मोस्टली वो या तो ओपन ग्राउंड में इंस्टॉल होते हैं या तो आपके घर की छत के ऊपर लगे होते हैं, ठीक है. इफ़ आई टॉक अबाउट जो हाउस होल्ड रूफ्स, उसमें क्या होता है कि आप रोज़ाना उसको ऑब्जर्व नहीं कर सकते कि वो क्या उसके उन पैनल्स को सफाई की ज़रूरत है या नहीं. सो थ्रू दिस प्रेडिक्टिव मेंटेनेंस वी एक्चुअली थ्रू द एआई एल्गोरिथम थ्रू सम रूल्स थ्रू सम पैटर्न्स, जब आपका सोलर उस हद तक उस कैपेसिटी उसकी अपनी कैपेसिटी तक सोलर एनर्जी प्रोड्यूस नहीं करा तो वी बेस्ड ऑन सम डिसीजन मेक श्योर टू प्रेडिक्ट दैट इट रिक्वायर्स क्लीनिंग नाउ, राइट. So there is no hardware level stuff involved. We are achieving all this stuff through the software. And this customer support and chatbot. As I talked about, we have two kinds of data sets. One is time series based data, which is captured at multiple granularity. And the other one is this customer support data actually. How is this customer support data actually collected? So on whoever house this particular system is installed, or if you are inquiring about these systems. So what actually happens, the clients make call to our NOC teams, right. This is one aspect of that data collection. The other data collection aspect is if a fault or any diagnosis occur on your system. So all these stuff actually gets logged onto our cloud, right. So for this we actually use Jira service management. So there are issues that comes from your queries or they are either automated based on the system's fault prediction. So we have both these pipeline that collects data and stores it for our future use, right. So what is our future use actually here? The chatbots. Let's talk about the chatbots later. This time series data. As you can see here that you have yellow graph for solar energy, purple one for load, grid, and the battery. All of the actions, all of the stuff happening at your system is logged 24/7 onto our cloud. Right? We maintain every data. So, what do we have at our cloud? We have around 10,000 plus systems, right? And all these machine learning stuff happens at our cloud, right? So we have our raw data that is either in Elasticsearch or ScyllaDB. So what we actually do is we create the ETL pipelines. What are these ETL pipelines? The ETL stands for extract, transform, and load, right? So we get all the data from our DBs through this ETL pipeline, do the feature detection on this part, and for the model. As you might be aware of this model training, we have a model, we observe its performance, and then we, in order to improve the accuracy, we try to do this optimization curve, which we actually tune hyperparameters for improving the accuracy of the particular model. Same goes for the stuff here in our cloud. For each system we have a particular model, right? So that particular model actually predicts your solar your outages, your load, your batteries activity at the moment. So what are key components here? As I talk about this data ingestion onto the cloud, our systems actually make use of these APIs and send the data towards the cloud. So there are two kinds of APIs that you might be aware of. One is REST API, the most famous one. The other one recently invented by Facebook, the GraphQL, right? So what is the difference between this REST APIs and GraphQL? So when you actually demand some data from the through REST API, then it gives you collective response of that particular API. But when it comes to the GraphQL, you actually get to retrieve only the particular data you only need, right? As I talked about this, these three, solar and load and outages, if I want to retrieve only the load part, then I can definitely make one single API through the GraphQL. But if I want to do in the REST API, then I will have to retrieve all three of those at once. So this is where we actually ingest. This is how actually we ingest the data into our cloud, right? That time feature in AI for ML pipeline. So what kind of data we have? We have historical data of PV, load, outages, and battery health. And based on these data, we engineer features. Like if I talk about traditional machine learning, then there are features like day, month, year, on what particular instance the system was actually actually generated what kind of data. So this actually comes from these features. So model trainings, prediction serving, orchestrations of pipelines, performance monitoring, MLOps. These are this is a bigger picture of all this stuff. So we utilize multiple models for training. We have, if I talk about the environment of how we actually develop these machine learning algorithms, we have three types of environment. One is dev environment. When a developer is actually working and doing all the code, they actually do that in the dev environment. So then the other step comes in when we actually deploy that model, where the developer and the QA associated on that task actually does the testing on it. So that is the staging stage, right? So when we have tested all the stuff, we actually port these models, port these APIs towards the production environment, right? So this is where actually the production environment is actually serving the customer systems and the customer queries. So prediction serving. So when all those models are actually trained, what we actually do, these are trained through the ML ops pipeline, we actually get serving from that system model. So what we actually utilize in our pipeline, that is the ML flow. We do all the data versioning, all the machine learning models versioning through this ML flow framework, which is actually an open source framework. So what it does, it registers a model that will be utilized for predictions against each of the particular system on the cloud. What this prediction serving pipeline actually does is it asks for particular systems model which is actually trained on the latest data, right? So it asks for the model, it gets the model from that model registry and then makes prediction safe and saves those into the DB, right? So the performance monitoring. There are monitoring like, if I talk about the development stage and the testing stage, we actually log the performances when we are actually training the data, right? So we get to achieve R2 score, mean absolute error, mean squared error, right? So, but this is during the development and the model training stage. The model actually, when it's serving the prediction, actually saves the forecast of next couple of days, right? So that is actually in the future. When monitoring these performances, what we actually do is wait for the ground truths of next 2 days. Then when those when that time is met, we actually compare both the forecast and the ground truth, and based on that, we actually monitor our machine learning models on all of the systems of the cloud on a dashboard, right? So all of this actually, this model registry and the model versioning, data versioning goes through this ML ops. This is kind of a bigger picture. So this is where on a particular time, for example, let's say a cron job actually runs that retrieves data from your database, right? Then does this orchestrated experiment of data validation, preparation, training, evaluation, and the model validation, which I talked about, that R2 score and mean absolute error. So all this source code actually gets put into our Bitbucket. We utilize the Bitbucket for all this stuff. So when this pipeline is actually deployed, we do the batch processing on that pipeline. That is where I was mentioning the prediction serving part. So we actually take in batches from that particular model registry where all the models against that, against all the cloud systems are located. So when all of these predictions are saved, we will perform as I discussed. Moving further, what kind of models we can have? As I talked about the staging environment. On staging, we actually utilize lots of models. For some of them are mentioned. We have from XGBoost to the NBeats and N8. These are the latest models, and you might have heard about the models like transformers being used for that. So how we actually make choice of these models. So as I said, that the number of systems is quite huge. Like it is expected to increase in future, 10,000, maybe 15,000, maybe 20,000. So we make sure to create the models that are actually low in runtime, right? That are not particularly heavy, like transformer model like quite huge. Even the LST model take quite a bit of time to make. But we have done experiments like we trained these models on good chunk of data, like we have past 2 years of historical data. We first train them on that particular data and then make use of online learning. So what is online learning? We get we get data at every instant, right? For example, at before 10 days, I trained a big model. So on every day or every week or every scheduled interval, that particular models in the registry actually gets pulled into our training pipeline, and what we actually do is continuous training. So if we first train that on 2 years of data, then we in the next iteration we train that on either 1 day of data or either 7 days of data. So this is actually